Hello everyone. In this video, I am going to simplify one question based on graphical convolution. Now, here is the question. Evaluate the convolution of f1 of t and f2 of t as shown below and plot the evaluated waveform. Now, in this question, they given two continuous time domain signals like f1 of t and f2 of t, and we need to find out the output signal y of t by using graphical convolution method. I already simplified one question based on graphical convolution, and the respective link I am going to provide in the description box. If you have any doubt, you go through that one. And this question is also same procedure we are going to follow. Now here, let us consider two signals f1 of t and f2 of t. The convolution of two signals is given by equation like f1 of t convolution f2 of t is equal to integration minus infinity to plus infinity f1 of tau f2 of t minus tau d tau. This is the principle we know already by using the continuous time domain signals x of t and h of t. By using that principle, we solve some problems. Now here also same just like two signals, but here it is denoting that f1 of t and f2 of t. Here we know that convolution obeys commutative property. That is f1 of t convolution f2 of t is equal to f2 of t convolution f1 of t. Now whatever the output signal we may find by using this equation 1, and the same result we are going to obtain with this principle also. Like f2 of t convolution f1 of t is equal to integration minus infinity to plus infinity f2 of tau f1 of t minus tau d tau. Now in this video I am going to solve this question based on two principles like equation 1 and equation 2 also, and I am going to show the result is also same, and at the end of this video I am going to provide the waveform of output signal y of t is also. Now before going to do the graphical convolution method, firstly, we need to find out the mathematical equations for the given two signals. Here, this figure A is going to show the signal regarding f1 of t, and this figure B is going to show the signal regarding f2 of t signal. Now the mathematical equations for given signals f1 of t and f2 of t are as follows. Now here f1 of t will be equal to 5 in the interval 0 less than or equal to t less than or equal to 2. Now in this figure it is showing, and f1 of t will be equal to minus 5t plus 50 in the interval 2 less than or equal to t less than or equal to 3. And this f1 of t signal will be 0 in other limits. So this f1 of t will be equal to 0 otherwise. Now this in the limit 2 to 3, this equation can be found out in this manner. Now here coming to this second signal f2 of t will be equal to 10t in the interval 0 less than or equal to t less than or equal to 1, and f2 of t will be equal to 0 otherwise, means in other time instance other than 0 to 1, the f2 of t signal will be 0. Here it is showing in figure B, and this equation can be find out by using in this manner. Now by using graphical convolution procedure steps, we will find out the output signal y of t. Now here in step 1, we need to draw the given two signals in terms of independent variable tau. So here this is the figure regarding f1 of tau, and this is the figure regarding f2 of tau. Given both the signals, we draw with the independent variable tau. Now in next step 2, we need to find out the f2 of minus tau signal. That is nothing but by doing time reversal operation of this f2 of tau, we are going to find f2 of minus tau. When we are doing graphical convolution, the first one signal is going to be constant, and the other signal is going to find the reversal signal, and with that signal we are going to do the shifting operations. So here in this procedure, we considered that f1 of tau signal as a constant signal and f2 of tau as a moving signal. So here in step 1, firstly we have to draw with independent variable tau, and in step 2, firstly we need to find out the reversal of this second signal. So here this is the reversal of this f2 of tau, nothing but f2 of minus tau will be the reversal signal. Now next, after this we need to find out f2 of t minus tau signal. So that is nothing but we are going to consider a large negative time shift for this signal f2 of t minus tau, so that the time instances can be changed from 0 to t and minus 1 to t minus 1. That is nothing but we consider a large negative time shift number. In place of t, if you consider like minus 10 or minus 20, so that the signal will be coming in only second quadrant. So now moving to the step 3. Here in step 3, we need to draw both the signals f1 of tau and f2 of t minus tau on same tau axis. So this is the figure. It is going to show f1 of tau and f2 of t minus tau on same tau axis. Now after that, here if we observe this figure, if there is any overlap in between the given two signals, in that overlapping period we need to integrate the two signals and we need to find out the output signal. If we observe this in step 3, if we observe this figure, if there is no any overlapping period, so now what we are doing, we are going to move the second signal towards right side, that is nothing but towards positive side, so that this is the figure we may observe when we are moving the f2 of t minus tau signal towards right side in a limited period. When this t will be equal to 0 less than or equal to t less than or equal to 2, this is the overlapping period we may observe in the time instant from 0 to t, so that we may find out the output signal y of t by considering the common time instance of this overlapping period, so that now we are going to find the output signal y of t. Now at different intervals of time, by shifting the second signal f2 of t minus tau towards the right side, we are going to find out the output signal y of t. Now if we shift the f2 of t minus tau towards right side in the interval from 0 to 2, this is the overlapping period we may observe. So the overlapping time period is going to be from 0 to t in the interval 0 to 2 time instance. So from this overlapping period, if we want to find out the output signal, this is the principle we are going to use, and in this common time integration limits, the mathematical expressions for f1 of tau will be 5 from this, and f2 of t minus tau will be 10 tau from this mathematical expression. If we simplify this, the output signal will be found as 25 t square in this interval. Now if we move the f2 of t minus tau towards right side, this is the overlapping period we may observe, but there is no change from this graph to this graph. There is no change in the first signal, second signal expression in the interval 0 less than or equal to t less than or equal to 2. So output signal y of t will not going to change. So coming to the other interval from time instance 2 less than or equal to t less than or equal to 3, this is the overlapping period we may observe between two signals f1 of tau and f2 of t minus tau. So commonly the integration limits, we may find it as from 2 to 3. The second signal f2 of t minus tau length is going to be only 1 unit. So, the common overlapping period we may observe from 2 to 3. So, the integration limits are from 2 to 3 and the first signal mathematical expression is going to be this one and second signal mathematical expression is going to be this one. So, from this if we simplify, the output signal we may find is equal to approximately 58. So, by using first method, that is nothing but by taking f1 of tau signal as constant and moving the second signal f2 of tau, we are find the output signal equations are in this manner. Now I will simplify by taking constant as f2 of tau and moving f1 of tau, and what is the answer we may observe. Now we will see. Now the same question here I am going to solve by considering f1 of t signal as moving and f2 of t signal as a constant signal. So here is the principle we are going to use. So f2 of t convolution f1 of t is equal to integration minus infinity to plus infinity f2 of tau and f1 of t minus tau d tau. Now here also we are going to use the same steps of graphical convolution procedure steps, and in step 1 we are indicating with independent variable tau, and in step 2 we are going to find the reversal of f1 of tau, nothing but f1 of minus tau, and in step 3 we need to draw both the signals f2 of tau and f1 of t minus tau on same tau axis by considering a large negative time shift t. And next, if we are going to move the f1 of t minus tau signal towards right side, if any overlapping period we are observing, we need to integrate both the signals on common time instance and find out the output signal. So here in the interval 0 to 2 time instance, here the output signal we may observe 50 t square by 2. And in the interval 2 to 3 time instance, the output signal we may observe as 58. Now this is going to tally the output signal with procedure 1 and with procedure 2. Now we need to draw the output signal y of t in a graph. So by this, the convolution is going to satisfy the commutative property. Thank you.